and his name is Mr. Obuzo Ezekiel. He's a GCP cloud and DevOps engineer. So let's clap on him. It's not easy. So yeah, thank you.
All right. Good afternoon, everyone. Please, those at the back, can you hear me? Good afternoon, everyone. So, let me host screen, right? Okay. So, good afternoon once again. My name is Obuso Ezekiel Omesi, and I'm into cloud engineering and DevOps in general. I mostly do, I do multi-cloud, AWS, Azure, GCP. But for the sake of what we do here, what we are doing here, I'll be talking more on Google Cloud. You get so um yeah, so yeah, who said that? Okay, on the presentation. Okay. So cloud computing basically is a very, very fundamental concept that as engineers we all supposed to know or we should know basically. Basically, cloud computing involves setting up resources on rented environment. So think of a situation where you have your own house, you generate your power by yourself, like you have your own generator and the rest. You spend more time maintaining that generator, you spend more time um, putting that generator in order, maintenance, fuel, and everything. But compared to grid electricity, you only just tap in from whatever the grid is supplying you, and then you pay for what you use. That's how cloud computing is. So cloud computing basically is getting on-demand resources from providers. You have the providers that we're talking about here, which is like Google Cloud. So Google Cloud offers environment or resources just like databases, compute environments, um, networking, storage, and the rest. What we do or what we all do as a developer is just to get these resources, based on the little one you want. For example, you won't go and start having to buy a server of 5 gig RAM when you just want to deploy like a small application. What you just go and do is you can get from a cloud environment and provision whatever you need at that point. For example, you want to deploy a small application, you can get a 1 gig server. They give you what they call a pay as you go setup, where you only pay for what you need at that particular point. So the main concept for today is we're talking about deploying our first Docker. The main concept is Google Cloud Run. But before we go into all those, we have to talk about the fundamental concepts, which is Docker. So how many of you here have the idea of Docker? Like you've heard Docker before, or you have used it before? Depends. Okay, so can you tell me what Docker is basically, based on experience? I've not really used Docker because okay, it's like container part. Okay, it's the most the most basic explanation. Okay, who else? The boss. Containers okay, okay. So that is also like it's a good version. Yeah, that's like the foundational explanation of everything. But anything hand up. Yeah, so I was just defining.
If you have a question, you have a mic.
Okay, okay, okay. Thank you.
So the way I've been Docker is, as developers, we usually have this problem of it works on my machine, but not working in production.
Yeah.
So the main usefulness of containerization applications like Docker is to containerize your app and configure it in your local machine such that once it's being deployed, it works with that environment that was, using the deployment. So that's how we use it.
Thank you very much. So the fundamental explanation of Docker is to help you to package your application in such a way that it runs on multiple environments without having to deal with environmental issues. For example, as a developer, you may be deploying your app, you may be developing your application on, let me use what we're familiar with most likely. You are developing your application in like Node 18, Node version 18. And then you want to now deploy traditionally, what people used to do before the whole sense of containerization CI/CD, what they do is after developing the application, they will now go and get servers, which is the traditional servers, do all the manual networking, public IP and all those stuff. Then they use what they call FTP to copy their code from their local machine to the server. Now, imagine that kind of scenario where you have to constantly be repeating that same process for every little change you want to make. Oh, I want to change a particular line. You now start copying, looking for that particular line to change in your code, then copying that particular line and going to where you have pasted it on your server and pasting that particular line. It's over time, it will not allow your application to scale. Application will never scale because you will definitely have to do thousands of lines of code, and you want to tell me that you want to constantly copying and pasting code. So that's where concept of containerization comes in. What Docker now helps you do is that you package your application, you build it into what they call an image. So an image is like a that's the way they call it an image, like a template of your application that can be run anyway. Just like the way you do what they call burning your video into a CD. I'm using normal day-to-day concept. So it will generate an image for you, and each image has what they call a version. Each image is a version. For every new image generate a new version of that image. And it's that image that you deploy to anywhere you want to deploy it. So it is a very, very, very fundamental yet very important concept that we need to know as engineers, no matter what you're doing, front end, back end. It's a fundamental concept. Now, like I said, Docker image. Docker image is like I said, templates where you build the application. You build the application and you turn it to what they call an image. Now, the same way you build the application, the same way you build your PHP application is different from the same way you build your Node.js application. So, as DevOps engineer, as cloud engineer, you must know how to write, build images across multiple programming languages. And that is where Docker files come in. So a Docker file will basically help you to, what a Docker file does is to help you to build your image, So I'll be running through, now, going back to the concept that we're talking about, from code to cloud, deploying your first application. Once you have an application, the first thing you need first is understand the application. Okay, this application is it a Python application, Flask, Django, or PHP? Various programming languages, or C#, any of them. The first step you need to do at that point is to write a Docker file. Now, what's the Docker file? A Docker file is a file that helps you to convert your application and its entirety into an image, which we talked about is like a blueprint that you can deploy to any environment. Now, it is when you are able to, it is your application being in an image form that you can now deploy to what we're talking about, which we will go into towards the end of the session. Can you still hear me? How am I not getting feedback from the back? Okay, so the first thing we're seeing here is okay. Now these are the different stages of
It's on. So I can't hear you, sir.
you don't recognize the mic is not. Okay, so the first thing I'm seeing here is from node 20 sleep as builder. So what we're doing in this first stage, what we're doing in this first stage is that we are selecting the foundational, like how like we then explain in such a way that, but when you want to dish out food, get that place where okay, this is what your food is, or this is where your food is complete. That is where this problem is coming from. It's talking about. Now your application is a Node.js application. So you have to use a Node.js image as the base. So you're trying to say that, okay, fetch the foundational image as a Node.js image. And since we're using version 20, we use 20. Now, you can see here. There are multiple images you can get. There are multiple version 20 images. But one of the aims of containerization is to ensure that it runs properly. Because one thing with images, especially when you're deploying, is that if you deploy an image wrongly, you may get a very heavy image, especially in a situation where may get a very heavy image and it will take longer to deploy. And if you are running some environments, it will take more cost. So we're using the Slim here because the Slim is like a lightweight. The Slim is like a lightweight version of the Node 20 image. Where okay, this is like how I put it. The way we have Facebook and Facebook Lite, that's basically how it works. So when you use images like this, it doesn't. There's what they call like optimization. It optimizes the code in such a way that at the final image, towards the final image, it's not as heavy. So once you pull for every version of the image that you want to probably are making changes, multiple changes, it is lightweight and it's easier to deploy. Now, this whole setup is we're doing what they call a multi-stage build. What they call a multi-stage build, meaning that instead of your Docker environment to run, your build to run at once, you are doing it in multiple stages, meaning that it will help to properly optimize this image. If you build it, if you run an image and you want to build it at once, it's very, very easy. Now, a Docker container is like a miniature server. It is not a server, but it is a very, very lightweight setup of a server. So what this work directory tells is you're trying to set up here is that within your Docker container that you want to set, create a folder called /app, which is ACC. So inside Docker container, where your code will run is in this /app, folder. So if you are able to access or to get into the Docker container, once you want to probably expect anything, you go to the /app folder and check it. Now we have installed the first one is Node 20 Slim as builder. The next work directory is app. Now we have set up the work directory, which is /app. In that inside the container, the next thing we're going to do is install the yarn environment. Now, for those of you that use front end and back end, especially around JavaScript, you will know npm and yeah. Please, one thing I want to correct before I move forward. I'm not a developer. I don't write dev code. So if you see any errors, especially in the dev side, please forgive me. Most of this dev code, I didn't write it myself because I don't really write dev code. It's mostly cloud code that I write. But going back, within your container environment, you now install your dependencies, which is your yarn and npm, depending on the environment. If you're using Python, that's Django and the rest, you install their requirements and all this stuff. It's just peculiar for this particular code base. Please note, it's not something that you would, okay, just go and copy and paste or something. What I'm trying to say in essence is that after you have started the build phase, that's in a typical Docker file. After you have started the build phase, you have created a work environment. The next thing you do is to install the dependency. Like I said, this particular Docker file is for this code base. Now, after installing the dependency, you move your package.json file and your yarn.log inside your work directory. So it's like a step by step. So when this thing runs, it will first of all install node 20, then the work directory to create it. And after it has installed a dependency, it will move your package.json, which is your dependencies file. This command is for the work directory. That's the app directory. Then now do yarn install. So for those people that have started a backend or front end project from scratch, you would see that this step will be very, very familiar with you because these are stuff that you probably be used to normally on your local. You know, after you set up your project, you do your npm install. Why people are not looking at me like I'm saying something strange? Everyone not done npm install and the day before. Okay, so yeah, the next one. So you're doing your yarn install, which is now in the work directory. So all these things now are happening within this setup, which is your work, which is your slash app, do your yarn install, you copy your source file. So this is the source file of the code. You're also now copying it into the source file in the work directory. Then after you have done this, you now build. So you know you have your normal npm build, you have your yarn build and the rest. Now the next step is the runtime stage. Next step is the runtime stage. Now this is after this one has built to create like your artifact and keep. Then after keeping your artifact, you now use that same artifact to now run the application. So it goes through all this from then going back to that work directory. Then to open a port 88, set the environment to production and open the port. Now if your application runs on another like a different port, this is where you will set it. The environmental variable port is equal to 88. Port is equal to 88. Then from build, it's going to find where it has set up. Now this like I said, this is a multi-stage build. This first setup is the build phase. The next setup is the runtime stage. Now from build which is going back to here, it is going to pick that package of JSON, pick it out, pick up the node modules out, and pick up this, which is where your artifacts are being stored. Then this is now you use the command, which is the cmd command, to now run where you do your node.js node.index.js and the rest. So in entirety, this whole setup helps you to build your image. You understand? When you are done with it, when it runs successfully, you see your image will be like a template that it will be able to run in multiple environments. Now let's move further. Now this is the local. This is like the back end setup that I did to test for the. I don't know if anybody can see me for the code. Now let's go to Google Cloud. That's the bonus. That's the main reason why. Now this is a Google Cloud environment. For us to talk about Cloud Run, we must first talk about Cloud Build. So let's talk about Cloud Build. So how many people here are familiar with the term CI/CD? Anybody? If you're familiar with CI/CD, please raise your hand, please. Okay. So this is Cloud Build. Most people that are familiar with CI/CD are, mostly use tools like GitHub Actions, Jenkins, which are the very, very popular CI/CD tools. So CI/CD basically is continuous integration, continuous deployment, and continuous delivery. It is a setup where you set a pipeline that moves your application from your local environment to wherever wherever you're deploying it to. Instead of the traditional copy and paste that people use to, just set up a simple CI/CD pipeline that moves that from your local machine to even the server or a Kubernetes environment and the rest. Now, Cloud Build is Google Cloud's native CI/CD tool that also does the same thing. It's not special. The only thing that is good for is that it integrates natively when you are trying to use Google Cloud products. For example, if you're using Cloud Run, which we are going to deploy to, we use Cloud. We cannot do it on other CI/CD tools, but Cloud Build helps to integrate it better since they're all under the Google ecosystem. Now, we have what they call triggers. Triggers, just the way the name implies, triggers. They are used to pipe or to clean onto your repository where your code is being, pushed to. So, for example, I finished building my code and I want to deploy it to a cloud environment. I normally push it to a GitHub repo, which is many people are familiar with. Now you will set up a trigger, which we will do. Set up a trigger to alert in such a way that once a push is being made to a particular repository, it should pick it up and then start the build process. That's what a trigger is. So for every time you finish writing your stuff and you push, probably you may work in an environment where okay, you're not the one directly pushing. Let's say you have a dev environment or a production environment. After writing your code, you have done all the QA checks and everything. Once it has been pushed to a particular environment, the trigger will kick in and then start building that application. But if you not build when there is no Cloud Build YAML file, so this is how it cloud. Now, if you want your application to be able to, if you want Cloud Build to be able to pick your application, there is what they call a Cloud Build YAML file. Now, after creating your Docker file, you create your Cloud Build YAML file. Now, in a typical Cloud Build YAML file, there are the steps. Now, these steps involve build, push, and deploy. This is substitution. Substitutions are like if you want to set environmental variables, or you have a particular variable that you want to constantly keep calling in the pipeline code, but you don't want to just keep constantly, you can set them up as substitutions. That's what substitutions are. Then this one is for cloud logging. But the main bone of contention now is the step. Now you can see this step now. Each step will have a name, will have an ID, and will have an argument. Now, this pipeline code contains 3 steps, which is the build image. Now, what this will do is that it will build your Docker file, what you have set in your Docker file. To build it, it will build everything you have written here. It will build everything you've written here into an image using this argument build. So this is the so arguments are like CLI commands that you will run. You get. So ideally, when you want to build a Docker file locally, you do Docker build and then you tag it, which is giving it a label. But now within the environment, within the cloud build environment, you just do the build and then you tag, which is -t. Now the tag is going to set going to be very peculiar, which is your region, the US Central One. There are different regions in the Google Cloud environment. We won't want to go into that now. But ideally, it's like US Central One is like the main region by default. To tag it, then it's going to add this project ID. So a project ID, a project on Google Cloud is your environment where you are working in. So on a Google Cloud, there's like a project. Each setup you want to do have a project. So that my project now, on my project, I can set a database. I can set different things. So we are working on a particular project. So you get the project ID as well, and then this other name and the service name, which is this. So this will be the full tag or the label of the application. Now it has built it to build it into an image. Build it into an image. Then the next step will be to push the image. Now there's what they call an artifact registry, which is also owned by Google as well. So ideally, traditionally, what people do is when they build an image, they want to call Docker Hub, which is Docker's own image repository. Like I said, your image is like a template of your software, but you have to keep it safe. Yeah, you have to always keep it safe. Still your software, but it's just like a photograph, basically a snapshot of your software containing every environment and the rest. So people store it in what they call artifact registry. All cloud providers have the artifact registry. And if you want to be a cloud agnostic, which is you don't want to depend on any cloud provider, there's Docker Hub, which is the Docker Hub is like the traditional way of storing. But here, for the purpose of this training, we would deploy it to artifact registry, Google's artifact registry. Then deploy your cloud run. So the next step, now after it has deployed that image to artifact registry, to now get that image and then deploy to cloud run. So by using the argument run, deploy, service name is still here, the region, the platform, the managed platform. Now allow authenticated. There are some sites that you would want to enter. They will tell you you don't have permission to view this site. So we allow authenticated, meaning that particular site we are trying to build is public. It's a public site that is open to everyone. So when somebody clicks on the URL, they will see like the site publicly. Ingress all, which is same thing. Then port 8080. Our application is 8080, so we have to open port 8080 in the how to open port 8080 on the cloud run. Now, max instances. The good thing about cloud run is that it's scalable. So at first, when you apply, so on the professional server, when you get a server and you deploy your application on your server, if there's a high traffic on that particular server, the server will most likely go down because you won't be able to handle that server, that traffic. Now that's why people are switching to Cloud Run, because Cloud Run has a better way of scalability, meaning that the first deployment, to be one setup, like one deployment, one instance, I mean the right wrong word, to be one instance. Now we're setting max instances to 3. That means anytime the traffic increases, add another instance, which is called auto scaling. So Cloud Run has benefits of auto scaling, meaning that the max instance should be 3. That means the instances can scale between 1 and 3. Then if probably, as a cloud engineer, you have issues and okay, the server is, people are accessing the server more, you can, increase it to as much as you want, depending on the cost constraints of your organization. Now, if we go back, yeah, so this is, like I said, this is cloud build. Let's go back to cloud run. Let's go to cloud run. I'll just show everybody all the environment before we deploy anything. This code is already on GitHub, so I will just put the trigger. So this is cloud run. It's cloud run. It's a service. This is a fully managed. You can see here, it's a fully managed that allows you to run your code, function, or container on top of Google's highly scalable infrastructure. Creating any source will enable the cloud on API. So you can actually connect your repository direct, but for best practice, we will implement what we talked about, CI/CD. That every time we want to do us. Now there's also the artifact registry. This is Google Cloud's native, registry. I don't know if I delete that. The old one. So for every image we are going to build, and this is the one that to delete this. So this is the code. This is our code base on GitHub. Unfortunately, we're using GitHub because Google Cloud disabled their repository for I don't know for what reason. If not, we could have preferred everything to be within the same Google Cloud environment. We're using GitHub now. Now, if you want to connect your project to your cloud build, what you need to do is the repository manager. I've not used it before, so just mostly, but yeah, just mostly GitHub as well. Just mostly GitHub, yeah. So go to triggers now. If you want to deploy the application to still simulate that application to GitHub. Now you see triggers. First thing you need to create a trigger. Create a trigger. Once you create a trigger, let us do it. Now you can see events, repository. You can see push to a branch. That means trying to say whenever a push that particular branch you want to commit, you want to attach here. That's when this whole trigger should go. You can see push to a branch. You can see source. build repository. Now, here that you will put the repository, repository, and then it will do authentication of your Google project, and you push it. Then you see the branch. You check on the project, you will see when the main branch, that's what the project is. So you put it as a name, so it's clear. You can see also the tested. Now it's configuration. Now this configuration means that you are going now to set it in such a way that your Google Cloud environment must be able to see this your cloud build of YAML. You must be able to see where it is. If it's in a folder, so for example, now can do build, can do a folder called build, and then inside the folder to cloud build YAML inside. After doing that, you will not come and do auto detected here. Because auto detected just automatically scans this front page. So if it does not find a cloud build, the cloud build here, your environment will fail. So if you have like a folder, let's say you have after source now, you have build, and then that build, how this folder is. You go back and you put the cloud configuration file, then you set the folder where it is. Or it's also detected because yeah, then now another thing you need to also do is service account, because service account is like permission that your GitHub has to give, your Google Cloud has to give your GitHub to be able to do all those transactions. So ideally, we're using this particular setup, but we can do account. So let me show you something. So in Google Cloud, there's what they call IAM, which is Identity and Asset Management. The cloud to cloud run. That's one thing you do with cloud engineering. There are a lot of permissions. You have to ensure that this one has permissions. So that you have to set a service account. That service account should ensure that your cloud build can have permission to build and to put permissions. You go to go to service account. You can see this our service account that we permission.
And you can see that particular service account that we want to use has Cloud Run admin, which is full control over all Cloud Run resources. So for any time you want to push, you must set a service account that has the permission to actually build.
You can see that particular service account that we want to use.
Build it.
Has Cloud admin.
And after building, when time to push, to mark X that failed, permission denied. So you have to set this up to have Cloud Run admin.
There are multiple, there are a lot of setups that you cannot go through, but this one is full control over all Cloud Run resources. There are storage objects, there are a lot of all of them. So let's go back. I'm going back to so now I've set it up. When you click on create, just to create the this is the trigger now. Now you can see that it's connected to our repository, which is this. So repository, and yeah. So what we want to do now is to click on run. Once we click on run trigger, to go to the main branch and then run the trigger. you can see that it's currently running the build. So now it's going to pick from here, it's going to pick from the latest commit, which is this particular commit that you see. And to start building the image. You can see build image. So this is what it's doing. It's building the image and doing all those setups. Step two, which is the second step of our Docker file. Creating a work directory. Yeah, so this is how it's going to do. So when it's done, it's going to show all green. That's when you know, okay, your deployment is successful. So after this one now, we will go back to the code and just, also I want to change anything, but we just add a comment and then push. So you will see when it is automatically triggered. Because like I said, it only triggers when there's a push to the branch. So that's what we mean by deploying your first Docker app. So going back to what I said before, the first step you need to do is creating a Docker file. Whenever you're given a project, you'll be like, oh, you as a developer self, you actually even deploy your own projects at some time. Most times people are dependent on platform as a service, which is like Vercel and Heroku and all those setups, which is valid, for normal projects. But sometimes in high, scale projects, you need to, for high scale projects, you will need to deploy the applications yourself. So the first thing you do is to write a Docker file. After writing a Docker file, to write a CI/CD pipeline code, you must not be, if you're working in a Google Cloud environment, you write a cloud build. If you're working in there's GitHub Actions, there's Azure DevOps, and the rest. Then you come to cloud build here, you set up your trigger, and then it's just basically automatic. So from now henceforth, once everything has worked, for every new change you want to make, probably after deploying, the client will want to like change something. All you just need to do is to go back to your code base, run your change, and you push to run the whole pipeline again, the whole build, push and deploy. And that's why you will see that in a typical code environment, updates easily come in almost every time because it's a very, very simple process rather than the traditional copying and pasting that we are used to. So yeah, you can see that the build phase has gone through. Let's see. And this one can run all the steps in our Docker file and then successfully tag. I can tag this based on the tag that we set. US is one practice project. Now these are our project ID. Our project is practice project. Practice project. Then on the cloud, run, source, deploy, and the rest. Now this is the commit ID. Now what we did is that we set our code to be versioned according to the commit ID. So this is the commit ID for this particular commit. Commit ID for this particular commit. So our image will be versioned according to the commit ID. So that if there's an issue with the image, you will know the exact commit that caused the image and you can probably roll back to a more stable commit. So this is our artifact repository. You can see 3 minutes ago, just pushed it 3 minutes ago. So this is the particular image that we just pushed. You can see this is the image. We just tagged differently. Now let's go to Cloud Run. Of artifact registry. It's where the image that has been built before it's deployed, it stores the image, artifact registry. Then it is now from artifact registry that it now deploys to Cloud Run. It's a 3-step process. To build the image, store it, now use that same image to deploy. Then after for every commit, for every change, it has a new version of the image, like that, a new version. And that newest version now that is getting deployed. So a situation where probably you have some chaos in the new version, you can roll back to the older version and deploy it like that. So it's like a chain. That's what they call it, a pipeline, like a code pipeline from the build phase, from your code to deployment. You have the build, push, and there's also need to be a test in between. But like I said, I'm not a developer, so in a normal production environment, there will be a test. After the build, you test, then push. Like that. So now, this is how your Cloud Run will come. It will give you a URL, which is, you can observe everything here. You can create uptime checks. This uptime checks now this is where the name implies, uptime checks. You get, if your application goes down for any reason, to send you an email so that you can easily troubleshoot and catch up with it. That's what uptime checks are. Then there are the metrics. So the reason why there are no metrics now is because you just deployed. Probably as people keep on using the application over time, you see a lot of graphs here. You see some, graphs. So you will know, just basically knowing, just basically helping you to know what's going on. Yes, within the infrastructure. Then there are just a lot of container instance count. Now you can see that this is one. Based on what I mentioned before, container instance can mean that there's currently just one instance running our application. If, for example, now the application now gets deployed, to production, and a high amount of traffic hits. Remember in our cloud builder, we read max instances is 3. You will see it here that it has increased to 3 or it has increased to 2. If the traffic goes down, go back to 1. So 1 is like the minimum. It always has to be 1. Then you can set it as high as you want, depending on, like I said, depending on the cost implication of your company, because the company will be able to say, oh, I cannot manage 5 servers, so drop it down, depends. So this is just 1. So it's currently running on 1 instance. And they'll just give you a lot of CPU utilization is 5%. And yeah, so this is all the metrics that you will see. This is the logs you will see as well. These are all SRE related stuff, so I don't want to go deep into it. But yeah, to help you to monitor application. Now, if you want to see, these are all helping you to monitor everything. Now, this is the URL to set for you. Once you click on it, to take you to this is docs. This is docs right here. Okay, sorry. That's docs. This is a typical background. All right. So this is the application that is deployed on Cloud Run. It's the same thing with our local environment here. Same thing with our local environment here that's actually running here. So first of all, before I move forward, any question? Anybody have any questions so far? Okay.
So does that mean that my repo needs to be on public all the
I
time?
can't hear you.
Does that mean that my repo needs to be on public all the time? If you set your repo to private and you make changes, for instance, Will
No,
it,
your repo can be private.
and it will still send the changes?
Yes,
Okay.
it will still send. Like I said, that there's what they call an authentication that goes on. The reason why my own did not go on because I've actually used the repo before. But like in my company now, we use private repos. So what we do is that the organization owner of your Google Cloud would send, your company, most companies have like organizations, GitHub organizations. So once you want to like deploy, you just connect it, and then the organization owner of that GitHub account will have to like approve that Google Cloud is trying to connect. Once they have approved it, the connection will go. And you can, once you set up the trigger, it will trigger automatically. You can connect private repos to work seamlessly. Any other questions?
Somebody here.
Okay.
All right, I have two questions.
Okay.
This Docker, it seems like it's for web only. Does it work on mobile?
I've not used it on mobile before.
Okay, so I want to ask, what other
Yeah,
trigger
it should work on mobile.
work on mobile?
Me, I've not used
not
on
used.
mobile before.
What other trigger options do we have? Because where I work,
What do you mean by trigger options?
you said, for example, when you push, it should trigger and deploy.
Okay.
What other options do we have? Because most times where we work, we have
Uh,
more than one person working on a project,
yeah.
and we don't want to deploy on push.
So ideally, what I use is that there's always like an environment that goes straight to deployment. Whether it's a dev environment, a staging environment, or push environment. It's not everybody that will deploy to a dev environment. You get. So it's that dev environment now that we go straight to that dev branch that we go straight to deploy that to the dev deployment.
Okay, so once you push to that branch,
Okay?
so once you push to that branch,
Yes, once you
deploys.
push that branch. So whatever people will do outside the branch, once that's been, put together and as sent to the dev branch, that's when it will now trigger. So the deployment work per branch. You're setting it per branch, not to the repo. You understand? It's not per repo, it's per branch. So some people can just say, okay, I pull changes on the dev. I now check out to my own branch. You know the whole stuff now. Check out my own branch. I do all my changes, everything. Once I push to my own branch, which is Ezekiel, etc. Once I push, in a typical environment, your QA engineer or your product manager or your engineering manager will review, do all those review and all those stuff. Once they review and everything, well, that's when they will now merge to what dev branch. It's now on that merge that the deployment will kick in. So if there's any other repo, there's any other branch before that, it's not even concerned, but you are mapping it per branch. You get. That's what it is. Any other questions? Someone here wants to ask, yeah?
So, lovely class. Yeah, so I'm trying to rationalize what is going to be the point of using like GitHub, Pepsi GitHub, using Google Build over just playing GitHub actions, push straight to maybe a traditional Docker place to keep your, apart from artifact repository has the artifacts library has the whole IAMs that you can use to add permissions. So what else? Because I know once you keep running the build, to keep incurring prices. So for like small scale organizations, how are you going to rationalize it over just playing GitHub actions?
I will not really talk rationality. The reason why we're actually using these tools is because of we're in a Google environment, basically. But it all depends on what you want. I'm not trying to let you know the difference between what people are used to, or what other people in other environments are used to compared to the Google, products that offer that same stuff. But ideally, you can use GitHub Actions. Me, I'm outside because where I work, it's also a Google partner. We're a Google partner as well. So we use mostly Google tools for everything. Like our rationale is that if it's not on Google, everything you want to do, check on Google first. If it's not on Google, find an alternative. So we use Google setup for almost everything from AI, deployment, everything. So, but you can still use GitHub Actions and the rest of them to do whatever you want to. You can also connect your GitHub Actions to Cloud Runner or any other environment. It depends on what, like I said, as I always been saying, your your company or your organization has to make that decision. You get it's not left for you can also help them make decision, but it has to come to a unified decision because it's still based on cost and management, basically. You get so yeah. Any other question? Okay. Like I said, it depends on what your it depends on what you okay.
Is it possible to put a cap on
Like I said,
distances?
it depends on your organizational needs. You cannot like go and set. I know that for AWS, what they call a service quota, but I've not used a service quota for GCP. But it depends on your environment, basically. So your probably your engineering manager will be like, okay, let us be expecting XYZ amount of traffic within the next, let's say 6 months. Let us cap it at 10 because of we are expecting XYZ traffic. So 10 should be able to manage this traffic. You get it is now when okay, probably in the next 6 months, people don't meet up, then you can either you reduce or what I'm like trying to say is that cloud run enables you to properly manage scalability. Not to overthink, oh, how like that traditionally now once you want applications are going higher, your head is like, let me go and buy more servers to attach to this one, get that kind of thing. But for this kind of setup now, you don't have to overly think about infrastructure. Just based on your budget, you can adjust this or decrease, basically. So it depends on you can go as high as 15, 20, you get instances, but depends on, like I said, the organizational needs. Okay.
So basically, if you don't meet the high targets for the number of servers to spawn,
I can hear you.
if you don't meet the maximum, like the limit that you set for the number of
You
servers,
can drop it down.
if you don't meet it,
Uh,
it doesn't make you spend more.
you spend and say now you be monitoring now. That's why this setup are here. That's why all this stuff are here. That's why all these that's why all these metrics are here. Everything like when you are deploying, once people actually start using this application, you are monitoring everything here. Everything is coming through here. Requests, traffic, everything. So it is not from here that you'll be able to make that decision. Should we reduce? Everything is that's what they call cost optimization. So, okay. Yeah.
You don't get to exhaust it ever. So even if before you make a decision that okay, we are not reaching this amount,
Yeah.
let's reduce it. Why you haven't used that resource? Do you pay for it?
Yes, and you pay for it.
You pay
Pay
for
as
it.
you go. Pay as you every resource we spin up, you pay as you go resource. So if you pay for it at the end of the month, first, second, third of the new month, they give you your bill and you pay for it. Yeah.
Okay, among other things that you said, I want to say that one of the things I'm grabbing is basically our traditional way of copy and paste made easy, right?
I can hear you.
Okay, I say that among other things that you have said, right?
Yeah.
Our traditional way of copy and paste made easy among other things that you have said.
How is copy and paste maybe?
Okay, you are like,
So I was trying to let you know that before the whole continuous integration, when people want to push new versions of software, they will write the code, they will write the new version of the code, and use what they call FTP. They use what they call FTP to copy the code from their laptop to the server, like that. Every new change like that at different points. So if you need a change now, and then for in Nigeria where the internet is not even stable, imagine copying code of over 1,000 lines and the thing just cut in between. You can't start handling the middle, have to start from the beginning, all this kind of setup. So it doesn't make sense redundant because you cannot push code on the fly. That's why you see now you can wake up one morning and your favorite app have a new interface or they have a new future. Because why? CICD has made it possible for software to be easily, so you can easily make changes on the code. So I won't say traditional copy and paste, but traditional copy and paste was not even as efficient. And so that's why, as as time seems to evolve, coming forward and the rest of them. Is there any other question? Okay. Okay. Um, Mike, please.
I've been hearing pay as you go, pay as you go. For a person like me that wants to start this, is there any free environment we can to start up?
Yeah, I heard something about sharing credit. Yeah, when you want to like it's credit now, they'll give you, I don't know, they'll talk about it later. Okay. Okay. So every resource is spin off counts hourly. Every hour it counts, can be $0.01, can be $0.1, like that, depending on what you're using. So it accumulates at the end of the month and they send you your bill like that every month. So that's what cloud computing. You have access to whatever you need. But at the end of the month you pay. That's what it is. So yeah, I think I'm going to round up here. Yeah, I think I'm going to round up here. So in the absence of any questions, I've been able to show you Dockerfile, cloud build, why cloud build is important, and how you can move your code basically from your computer to your deployment, basically. So yeah, thank you very much. Yeah.